All right, we're going to look at seeing if we can find the pattern for number 3. So I have 7 halves, 7 fifths, 7 eighths, 7 elevenths, 1 half, and 7 over 17. So if I look at these, the thing that I notice is they all have a 7 in the numerator except for the second to last one. So I'd like to convert that one so it also has a 7 in the numerator so that hopefully I can find a pattern here. So I know 1 half, if I multiply that by 7 over 7, I'm going to get 7 over 14. So I can replace that 1 half with a 7 over 14. Okay, so let's get our table going. So I have n, 1, 2, 3, 4, 5, and 6. And then I'm going to put my terms in. So I have 7 halves, 7 fifths, 7 over 8, 7 over 11, 7 over 14, and 7 over 17. So I know that my numerator is going to be a 7 for my generic formula, so I'm going to go ahead and write that down. And then I just need to figure out what to do about the denominator. So I'm going to check these denominators to see if they're changing by the same number each time. So the difference between 2 and 5 would be that we added 3. From 5 to 8, we added 3. From 8 to 11, we added 3. So all of these look like we added 3. So if I start with 2 and I add 3 for each time that I go up a different number, I should be getting really close to what I need to do. The first one, though, when n is 1, I don't want to add 3. I want the 3 to go away. So the way I'm going to do that is I'm going to write that as n minus 1. So 2 plus 3 times n minus 1. So let's write out a few of these terms just to convince you that this is going to work. So when n is 1, I get 2 plus 3 times 0. So that goes away. So I get a 2. When n is 2, I get 2 plus 3 times 2 minus 1. So that gives me just a 3, and 3 plus 2 is 5. So that checks out. We'll do one more. When n is 3, I have 2 plus 3 times 3 minus 1. So that's a 2. So 2 times 3 is 6. Plus 2 gives me 8. So all 3 of those check out. So that works great as a formula. And I'm actually going to go ahead and simplify that. So I have 2 plus 3 times n minus 1 is 2 plus 3n minus 3. So it gives me 3n minus 1 as a total. So some of you may have been able to eyeball this and say, if I'm adding 3 each time, this is really 3 minus 1. Gives me 2. 5 is 6 minus 1, so that would be 3 times 2 minus 1. So some of you may have seen that this was 3n minus 1 to start with, and that's awesome. If not, this should give you kind of a good roadmap for how to figure that out. So my nth term, my f of n formula is going to be 7 over 3n minus 1.